Hi, I'd like to welcome all of you joining us today, our YouTube community. And my name is Edwin Robledo. I'm from the Fusion team. And with us today is going to be joining us is Jorge Garcia as well as Richard Hammerl. They'll be working with the chat, so you'll be able to see them there. Any questions that you want to post, you could actually talk to them there. So before we actually dive into Fusion 360, I wanted to go over some slides initially. That way I could better explain our workflows and some of the editor capabilities, just some fundamental aspects of it before we dive into Fusion. I felt that way you'll better understand how everything is working together. Okay. Therefore, I'm going to go ahead and start sharing my screen. Okay. So as I said, my name is Edwin Robledo, and with me today is Jorge Garcia. Also, Richard Hammerl is with us on the chat as well. Okay, so start here. Okay. Well, first of all, we're going to be seeing what the schematic editor. That's one of the first workspaces that we're going to see. The editors, I should say, not workspace, but the editor we're going to work. Now, the schematic editor is in where you can actually be putting together the logic of your design. This does not take into consideration absolutely no geometry regarding the circuit board in itself. It's basically you're making decisions of which components you're going to be using and how are they going to be connected between each other. Okay, so this is what the schematic editor is, a logical representation of the circuit board. The next editor we're going to be working with is the board editor. The board editor now takes into consideration any type of geometry that the circuit board is going to be using. If it's going to be a round shape, it's a square shape, rectangular shape. The traces are the connections that are in between the two components. Those connections derive from the schematic. The connections defined in the schematic actually come over to the circuit board, and it's up to us to either manually route them or use the auto router. And I'll explain a little bit about that when we go live with Fusion 360. In addition to that, we also have a component editor. Now, when you're working on a schematic, you're going to be accessing a repository of components. Those repositories are usually referred to as the repositories are usually referred to as libraries. Now, we have a team of librarians that are constantly adding more and more assets to our libraries to make them available for your designs. Now, we don't have them all, and there's millions more available by different manufacturers and providers as well. Now, we do have a library editor in Fusion 360 in which you could build your components, and it's actually pretty easy to use. And we do have calculators which make it actually much easier to create the component. And the benefit of it is that it will create the footprint, which is the part that goes on the circuit board, and the 3D model, the 3D model association, all in the same steps. I'll do my best to be able to demonstrate that. This is just a short demonstration we want to do today. We will continue doing more some next week as well. Now that we have an idea of the three editors, let's go ahead and talk about the actual workflow that you're going to be using with Fusion 360 if you're designing your electronics with it. It actually starts from the schematic editor. Now, from the schematic editor, you're going to actually be accessing the libraries. In the libraries, you're going to be placing components in your schematic. You're going to be accessing the libraries continuously and adding more information to your schematic. Once you place enough components on your schematic, you'll be defining your connections, which is basically these green lines that you see here. You're going to be actually placing those connections. Now, You don't have to finish the schematic to start working on the circuit board, but you can actually now start working on the board. So from the schematic, I'm going to go over to the circuit board. Now this is going to be a kind of a bidirectional workflow, because any modifications that you need to do to the schematic will actually affect the circuit board. There are certain modifications that could be done to the circuit board that actually will carry over to the schematic, such as renaming components, changing the value of components, or renaming connections. Those are actions that could be done on the circuit board level, which will be affected by that will actually update onto the schematic automatically. Now, with the advantage of Fusion 360, we do also include a 3D PCB editor. Now, this editor is only primarily going to be working with your 2D PCB. Okay, so the flow is going to be this flow is usually kind of goes that way. It goes in the direction of the circuit board over to the 3D PCB, but it does have the capability of I can make some modifications on the 3D PCB, such as moving components, and they actually get rerouted in the 3D PCB level, and that will actually be updated on my 2D PCB as well. So this is kind of like the game plan. We work from the schematic by accessing components, work with the board, back and forth between board and schematic, and from the board we actually create the 3D PCB. Now there's a step here that I'm not really including, but we're going to actually be demonstrating once we go live with Fusion 360. Okay. Now let's talk a little bit about workflows. This is the actual workflow, taking advantage of the electromechanical capabilities that we have with Fusion 360. One of them is that the enclosure, as you could see on my top left example that I have here, is that the enclosure actually determines the shape of my circuit board. It's actually very common in which that the mechanical engineer is actually leading the shape of the design that's going to be on the circuit board. Now there's instances in which the circuit board actually drives the design of the enclosure. It's possible that the circuit board actually needs to be with certain components placed in a certain way. There's a possibility that components as well as connectors need to be placed in a specific manner. Therefore, the enclosure needs to adapt to the circuit board. Those are the primary two workflows that I would like to mention, and I'll try to demonstrate today as well. With this explained, I'm going to go ahead and go live with Fusion 360. That way I could show a little bit about this. Okay. Now from Fusion 360, to be able to access the electronics capabilities embedded into Fusion 360, you're going to click on the File pull-down menu that you see right here. And you're going to select right here that option that says New Electronic Design. This is how this is going to start. Okay, I'll click here, New Electronic Design. Now this puts me on an electronic design panel. At this stage, I determine if I want to either link an existing schematic that I'm already working on, and that's this option right here, or I could actually start a brand new schematic. For our first tutorial, we're going to primarily be working with a brand new schematic. The same happens with the circuit board. Actually, I could link an existing circuit board to an existing schematic. Okay, that's one way. Or I could just start a brand new circuit board. In our example for today, we're going to actually start everything brand new. So let's go ahead and click on the schematic here, brand new schematic. And that brings us to the Schematic Editor. Now in the Schematic Editor, you'll notice that we have some pull-down menus, as you're used to. We also have our action menus as well. As you can see here, our design, that's our default. And everything has been created in a flow that way you could work from left to right. We have our information buttons. We have our show or our highlight buttons, our grid settings, our layer settings. When it comes to the schematic editor, usually don't work much with the layers, or you don't really change unless you're changing colors of the layers or anything like that. We have a duplicate, our paste, garbage, and everything else that you see here. Now these will change depending on which one you currently have active, as you can see from this point on. The validate, the automate, as well as the libraries. Now the first thing we want to do is we want to start adding components to our schematic. That's the first action. I realize that we actually started from the schematic. We started a brand new schematic. Okay, so we're at the schematic editor. This is what the schematic editor looks like. So what I'm going to do is click on the add command, and that's how we add components to our schematic. And we'll get a list of the current libraries that are currently available. These are the current repository of libraries that we have here. Now there are more that are available that you could download, and I'm going to show you how to do that right now, because I actually want to place a frame on my schematic, and the frame library is currently not available. Therefore, I'm going to click here on the bottom that says Open Library Manager. This actually gives me an information of all the libraries that I've been currently using on my design. Since my design doesn't have any components, it comes up blank. I'm going to go to the Available tab, and this is going to show me a list of libraries that are currently available on our cloud-based system. These are libraries that are contributed by our team. There are libraries that are actually contributed by manufacturers as well as distributors. So if you're looking for a component, always make sure that you go to the library manager and always take a look at this repository, because there's a lot of libraries that are currently available here. Now there's a search option, as you could see here. Since I'm looking for the frame library, I'm just going to go ahead and type frame. I'm going to select my frame, and I'm going to click on the option Use. This frame will now appear in my Use dialog box, as you could see here. It shows up right there. Since it's there already, I'll just go ahead and X out of this menu, and you'll see that it shows up right here. I'm going to expand that frame library because there's a frame in particular that I wish to use, which is this one, which is 8.5 by 11 inches. Usually what works well with any printer, paper size, letter size sheet. Now you'll notice that there's a cross here on our workspace right here. You'll see that right there. That's the origin of our page. That's our 00 marker. You could tell because if you were to move the mouse cursor here, you'll actually see 00 right here where you're having your coordinates being shown. I'll go ahead and place the leftmost corner of my frame at that point right there. I'm using the mouse cursor, the mouse wheel, to zoom in and zoom out. Extremely convenient. And I'll just match the origin with the 00 of the page as well. I'll do a left click to go ahead and place it. Automatically, another one is going to appear on my mouse cursor. That's okay. That's the way it's intended. And you're going to be able to notice in a few minutes why. Now, I want to go back to the Add command. Instead of hitting the Add command right here, I'm actually just going to hit the Escape key. You'll notice that the Add command automatically comes back. And I can now start selecting other components that I'm going to be using for our tutorial. Now, here we have a tutorial called Getting Started with Fusion 360. In essence, I'm going to be selecting all the components from this library that we'll be using. I'll go ahead and expand this library. And I'm just going to select from the RUS library, which is resistors US style. I'm going to select the 1206. I like using the 1206 because they kind of like really large, easy to hand solder, or if you have a reflow oven, they're actually pretty handy to use. Now that I'm in the editor and I'm actually placing components on my schematic, I selected the resistor. Now, first thing I want to let you see is that I could use the right mouse click to rotate my component, as you could see here. On the schematic editor, you could only rotate components in the increments of 90 degrees. I'm going to go ahead and place it using the left mouse key. And of course, I'm going to get another one attached to my mouse cursor. As we move the mouse, you'll see I have another one attached to my mouse cursor. I'll go ahead and place another one that we need here. I'll place a few more that we need. We need a total of 4 of them for our current design. Okay. Now that I've placed the components, I'm going to hit the escape key. I'm going to go ahead and use a 555 timer. We're just going to make a real simple design using the well-known 555 timer, as you know. Now the timer actually has multiple footprints that we could use. I'm just going to use the first one, which is the most common one, which is using the SOIC 8-pin package that you see right here. I'll click OK. It's going to be attached to my mouse cursor, as you can see. I'm just going to go ahead and rotate it, as you can see, using the right mouse key. And I could actually use my middle mouse button if I actually wanted to mirror the component as well. So I'll hit the middle mouse button. As you can see, it mirrors the component. In this essence, I don't really need it mirror. I'm just going to left click it and let it place there. I'm going to do a left click to go ahead and place it. Now I'm going to hit escape and go ahead and start grabbing some other components that I need. I'll be needing a capacitor as well. So let me go ahead and expand the capacitor library. And I'll use some 1206s as well from here as well. Okay. I need only 2 of these I'll be needing. So I'll put one here as well. I'll put one there. And that's it really. I'll hit escape. And now we're going to need, yes, a few our LEDs. So I'll go to our LEDs are here as well. Okay, so I'll go to the library called Optoelectronics, and from Optoelectronics I'll get the LEDs right here. I just use those most probably. Yeah, I could use those. Okay, and I'll go ahead and place them right here. Okay, now that I've placed my components on the schematic, now I'm going to go ahead and start defining my connections. The connections are going to be defined by using the net command. You'll see it right here. Whoops, sorry, I had to escape. And the net command is actually located on the top toolbar, as we see right there. That's the net command. Now make sure that you're using the net command. That's the only command you should actually be using to define your connections on the design. Click on the net command here, and I'll start just drawing our designs that we see. Now you'll notice that as soon as I get close to a pad connecting point, you see it turns into a bubble. That's just letting me know that that's the actual connecting point of that pin. So you can see, now I'll just left click and I'll start drawing this green line. A green line is actually the connection. Once I reach the destination where I want to go with it, you'll notice that that bubble appears right there as well. That means that the connection has been done successfully. It's very, very, very important that you understand that you should never, ever change the grid on the schematic. It's extreme. I can't stress that enough. It's very important that you work with the default grid, which is 0.1 inches. Don't change that grid at any point in time. If you do, there's a really good chance that the connections will not be able to be carried over to the circuit board. Now I'm just going to move this cap that I just put it off. I just put it off a little bit too far. Sorry. I just defined the connection right there. Okay. Now, one thing I wanted to let you know is that if I stop drawing my net, if I left click on an already existing net, you're going to actually get a junction point. This is just to let you know that the name of this net and the name of this net is exactly the same name, so it's the same connection. If the connections are just crossing over and a junction point does not appear, it just means that there is not a connection between those two components. Now I'm just going to go ahead and start making these connections really quick. That way the tutorial doesn't go too long. There's some other aspects of here that I actually want to show you. Now we're just going to go ahead and use the add command one more time to bring in our supply pins. That way we can connect our voltages as well as our voltage as well as our ground. So let me just go ahead and get to that library really quick. My voltage right here. I want to bring my voltage. I want to put my voltage here as well as here. Oops, sorry about that. There. Then I'll put my grounds. Okay. Primarily, the only thing that would need to indicate here is a way of bringing in the source of voltage into my design. But I'm not going to do that for sake of time. I just want to go ahead and move on with this. So this is what our schematic kind of looks like for now. Okay. So I'm going to save what I've done so far. And from the schematic, we're going to start making a circuit board. Now the circuit board is going to actually be primarily kind of done. All the components are going to move over for us automatically, but we will have to actually place them where they're going to go. So first of all, before we actually do that, I want to go over here and show you some movements. If I want to move the entire components, I could just left click and drag. You'll notice that a group gets formed, and I could left click and hold any center, any connecting point. I'm sorry, any origin of a component. Any of them. I'm just going to use this one because it's the most visible one, and I could actually move the group. You don't have to select the group command. You don't have to select the move command or anything like that. It will actually move for you, as you can see here. Okay, I could do the same thing as a group. I hit the escape key to just finish that group. I could just select this group I have here, and I could just select any origin of any of the components that you see here, and I could actually move this here as well. Now, as you select elements within your schematic, you're going to notice that your inspectors actually is going to be showing you the components that you have selected. At this point, you actually can select any component here and make some modifications right here. If you wish to fine-tune the components that you're seeing, there is an inspector here as well, which actually lets me design manager. Oh, the selection filter. I have it right here. So if I only want to be able to select components, I could select the option here that says device that you see right here on the left hand side here. So there's an option that's called devices, which would actually kind of like ignore everything else unless I select a device. The same thing goes for junction points. It will ignore anything else other than junction points and so forth. So this kind of lets you fine tune exactly what you're going to be grabbing on your design. Okay, now that the schematic is actually, it's not completed 100%, but it's enough for us to move on. You get the idea of placing components as well as defining connections. Now let's go ahead and save what we've done so far. Now I'm going to go back to the electronic panel and save from this point on because I want everything to be saved. So I'll just call it here, electronic design. Okay, and you'll notice that everything gets saved automatically for me. I'll return to the schematic, and from this point I'm going to go ahead and create a board. I'll click here where it says switch to PCB document, and this actually will bring in my circuit board for me. All my components with the connections that were actually defined on my schematic are there. It's actually, I guess the color is kind of dark, so you can't see them. If I select everything here, you'll be able to see them. You see those little air wires there? Those are the connections. Apparently, I need to change the tone of that layer. And they will show up next to an empty board that is already available for you. I could go ahead and now and actually just grab and make this smaller if I needed to, or I could actually just use an existing enclosure, do it that way. Now I'm going to go ahead and use an enclosure which I have ready to be able to use it here. Now the enclosure is kind of large for the amount of components that we're using, but it will better demonstrate how is that in the electromechanical workflow between Fusion 360 and how the electromechanical workflow Fusion 360 works. So let's go ahead and let me go ahead and get to my data panel, and let's go ahead and grab an enclosure that I have here. I'll select this one really quick. Now this is going to be really large, just because it's just a very large device. But I just want to put the point across here. So let me just go ahead. I actually turned off part of the body of it. That way I could access the inner workings of this drill. And actually, here we go. So here we go. So what I want to do is I want to put my circuit board in here. So the way I would do this is that, and I want the circuit board to sit actually on top of these standoffs that I have right here. I have 4 of them. Okay, they're approximately a 1/4 inch high, the standoffs. But I actually want the circuit board to avoid this hole that we have here as well, and I want my circuit board just to sit in here. This is kind of an odd shape that we would be using, and in Eagle to be able to draw the shape, in Fusion 360 in the PCB editor would not be very simple to do. So I'm just going to go ahead and do it here, because to define this geometry is a lot easier to do it at this point of the Fusion 360 mechanical editors other than the PCB editor. So now I'm going to go ahead and click on construct, select an offset plane. I'm going to select right here and click OK. Now this is my plane now. Now I'm going to go ahead and create a sketch at that offset, as you could see here. Now what I'm going to go ahead and I want to do is I want to project the bottom surface of this entire enclosure, as you could see. So I would go here and I would click on project include, and I would actually select the entire bottom here. Once I select this bottom, I would actually, once I have it selected, I would use the offset command and create the offset. I kind of did these steps already to define this PCB, as you could see right here. Oh, this sketch, I should say. I shouldn't call it PCB. This is the sketch I actually drew earlier today. Now I need to complete it because I need to project this portion that I have right here. That way it stays here. Oh, actually I already did. So this is going to be the shape of my PCB right here. I want this to be my circuit board shape. Now that I've actually done the offset and I have the shape that I want, I'll click on Finish Sketch. Now here comes, I click on Create and select Create 3D PCB. And I'm going to go ahead and select, let me turn on the sketch, it automatically turned it off for me. I want to select this profile. I don't need any of the other profiles. I only want this profile. Okay, I'll go ahead and click OK here. And this will bring me to the PCB editor, the 3D PCB editor. So basically, as you could see, I went from here, it brought me to the 3D PCB editor. I'm just going to go ahead and save this quickly. Now, I want to link the circuit board that I'm working already on our example, which is this one. I'm sorry. Okay. Right here. So I want to link that 3D PCB, that outline, I want to bring it into here. So the way I would do that is I'll click here on link, and I'm going to go ahead and associate it to okay, apparently I need to save it. I haven't saved it, so okay, I gotta save it. Okay, now that it's saved, okay, now I should be able to do the association. It was that easy. This is a profile that to draw in this circuit board editor would actually be take quite a bit of time. It wouldn't be simple to do. So by being able to project the profile, to project the surface on the enclosure and being able to bring it here only took a few mouse clicks. Okay. Now I'll go ahead and start populating my components into the board. In this case, I'll just bring them in all as one unit. And then once I have them here, I'll just go ahead and start moving them around one by one. Now, for time purpose, I'm not really being very careful with my placement, so because I'm just trying to do this as fast as possible. You have your zooming tools are on the bottom of the screen, as you can see right here. Here's my zooming tools as well. The interface is extremely similar to the one that you already have in the schematic editor as well. Extremely similar. So let me just accommodate these parts. That way we could do some manual routing. Click on the move command to have that active. If I start moving the components, if I right click, you'll see that they rotate. Now by default, they're going to rotate at increments of 90 degrees. Okay, that's going to be their default. Now you can go ahead and type in what value you want to rotate them if you need anything within 90 degrees or any specific angle that you would like to use. Let me just go ahead and place this here. Let me just move the attribute here. This is the name, the value attributes that you see there. And I'll just keep on moving more of my parts around. These are surface mount components, which are components that you sit on the top of the board, on the surface of the board. They do not have a profile on the other side of the board. Therefore, usually it makes it a lot easier for you to make smaller boards by using surface mount components. Now, the only step that was necessary that I did not do on the schematic, which actually would be of great value, is actually assigning the values to the components. I kind of skipped that step for sake of time, but it is actually a very important step. So I could go ahead and switch over to the schematic if necessary. And I could just do a right click on the components and select the value option and start giving it the values. You can see, I can just right click. And just keep on adding values to my components. Same for the capacitors. I start giving them values as well. And you see what's going on. So I'm just going part by part by part. Just go ahead and add its values to each one of the components. Okay. Now that I've added the values, let me go ahead and save what I've done so far. You'll see that everything will update here, in addition to the 3D PCB that we already have here now. Now, let me show you a few routing options that you have. First of all, I'd like to first talk about manual routing. Before we go there, let me go ahead and set up our environment before we begin routing. I'm going to go ahead to go to here where it says manufacturing rules, ERC and DRC. Here's where you're going to actually determine how many layers your board has. In this case, we have a 2-layer board. If you need more than 2 layers, you got many options. The editor in Fusion 360 actually is able to handle up to 16 layers. Under the clearance tab is where you're going to be setting up the distance preferences that you want. The sizes that we currently use already in Fusion 360 are pretty conservative. Therefore, getting your board manufactured should be, if you were to stick to these values, should be reliable enough under normal conditions. You have your distance parameters, such as how far is the copper going to be from the board outline, and as well as how far the vias, holes, and pads should be from each other. And there's many more, as you could see here. We're going to be hosting webinars, yes, on the DRC. That way you could get detailed explanations. The board outline, as you could see here, is this line right here, which is actually a line that is drawn on a layer called the dimension layer. You'll notice the difference between the shades of the color of the background and the board background. That way you could visually see what's the difference that you're having right now. Now that we've determined how many layers you wish to use and any other criteria we want, let's go ahead and go back to the design and let's try some manual routing. I'll click on the pull down route option. You could start routing right here on this line right here. You'll notice that when you begin routing, the width of that line is the minimum width that was actually selected under the design rule checker that I showed you a minute ago. As I move my mouse cursor, it will actually change. I could switch angles, as you could see here. These are the options that I have for the manual routing. Now, one of the nice things that we have is that, as you could tell, I'm trying to force it to create a short circuit. It won't let me. And the reason behind that is because I currently have the walk around obstacles enabled. If I wanted to be able to have full manual control, I would actually go here where it says ignore obstacles. This will actually give me full control of what I'm doing, but it will actually also do some shorts if I wanted to as well. Now, backspace that. Oops. Route. Okay, so I think I drew a line over here by mistake. Okay, that's the problem. Okay. Now, as you manually route, there'll be instances in which you actually want to switch layers. This is a 2-layer board, so I do have the capability of going between the top layer and the bottom layer. Those are the only 2-layer options that I currently have. By hitting the space bar, you'll notice that now I get a point of transition. In other words, known as a via. Now, the via size can be determined right here. This is where I'm setting up the via. Now, the via is actually automatically going to get a drill hole size. You could assign it that drill hole size. Now, the amount of the plating material that the via has, this amount that you see right here, this orange portion, is going to be automatically calculated based on the drill hole size. There's a reason behind that. Reason is basically is that way the via never will get drilled out entirely when actually it's going into the manufacturing process. Now, if I left click and I continue to route, you'll notice that it's coming out in green. Now, when it comes to the circuit board editor, it's imperative that you find a grid that is actually satisfactory to you to actually be able to have enough for solution to route your board. The grid command is right here on the top toolbar. It's always good to start with to have a kind of a fine grid. You don't want to go too fine because then it's going to get it's going to kind of shake too much. But it's okay to work with fine grids as well, depending on the technology that you're currently using on your design. I'm pressing and holding the middle mouse button, that way I could pan. Now, this is a surface mount component that is on the top layer. So therefore, I actually have to pop back up to the top layer to be able to complete the route. Hit the space bar once, I left click, and I continue to route. As I get to the connecting point to my destination, you're going to notice that a white X actually does appear. This is actually my connecting point right there. I'll left click, and you'll get a confirmation on the speakers letting you know that you actually have successfully connected. That's one way of doing some manual route. Now, we have some interactive routing capabilities as well. If I click here where it says the routing tool, I could quick route, and I could select the option quick route air wires. So here actually it will do its best to do a route for me as well, as you could see. Now, the nice thing of quick route is that I could use it in combination of manual route as well. So if I'm doing a manual route, let's say right here, I'm going here, I'll go to the top layer, to the bottom layer, pass across here, and I could just hit the enter key on your keyboard. I can go in here. Oop. Okay. Okay. And I guess I do have the quick route disabled. Okay. Now, I'm going to go ahead and rip up the board. Click here and rip up. I want to rip up the entire board. Rip up means that it's going to put it back in its original state. In other words, everything is going to go back to its air wire state or rat's nest state. Now, under quick route, you're going to find here something called the auto router. Now, when you're routing, it's actually, we prefer to recommend that you do your manual routing. That way you're in full control of your board and how the routing works. But the auto router, we do have one, and it actually works pretty good. It has multiple algorithms embedded, and I'll show that right now. As you could see, it's a 2-layer board, so it's actually going to select the preferred direction on each one automatically for me. I'm going to set the effort to medium. That means that how many routes it's going to do simultaneously. Now it does all the routes in parallel. They don't finish at the same time, but it runs them in parallel and give you all the results at the end. That way you could select which result best satisfies your design. I'll go ahead and click on OK. You see a maximum number of run threads. This is the maximum number. It could do up to 8. It may not have to do 8 because this design is kind of small, so it might just need 4 or 5, but it will go up to 8 if necessary. Those are 8 parallel threads running at simultaneously routing the board. I'll click on continue. Actually, it's going to do 10 of them. Oh, because I changed the effort level. I'll go ahead and click on start. Since it's a pretty small board, pretty simple board, we have all the routes already going. The first one is always called a topological router, which is it's an algorithm slightly different than a rip up and retry, which is what the other ones are actually using. Okay. Now I could browse the different route results that I have, as you could see, and select the one that you prefer to use. I usually try to select the ones with the least amount of VS. I'll click on End Job. Okay. Now that we have the routing done, I'll go ahead and save what we've accomplished so far. And we'll go ahead and update our 3D PCB. That way we could see our results there as well. This step might just take a minute or two to actually complete because it's actually building it entirely. Okay, there we go. It already completed it for me as well, as you could see there. Now the nice thing that we have is that on the 3D PCB, I actually can move these components if necessary, and it will be reflected on the 2D PCB as well. I'll go ahead and click on here, move my parts. Select here as well. Let me go ahead and move the part. I'll move this component. Now, look at the dialog box that opened up on the left-hand side. It actually has the option to, once I move this completed and I let go of my mouse cursor, I could select this option. That way it will actually update my routing for you. I'm going to go ahead and select that option that we have right here and go ahead and click OK. Option is just going to take a couple seconds because it's actually fixing it in the 2D PCB and reflecting it to our 3D PCB. As you could see, it actually completed my routing. Actually does a fairly good job at updating my routing. Now let's go ahead and push this modification over to my 2D PCB. I click on Modify and I select the option Push to 2D PCB. That way my 2D PCB will actually get updated as well. As you can see, the modification has been completed. Once you're satisfied with what you accomplished so far, I like to always come back to the electronic panel and save what I've done so far. That way I could keep track of my progress. As you notice, my 3D PCB at the bottom, my associated 3D PCB, that gets updated. On the left we have the top, on the right we have the bottom as well. Now that everything has actually been updated and we're working okay, now it's time to go ahead and start working on creating our manufacturing files to actually get the circuit board made. To do this, you're going to actually click on the manufacturing tool that we have right here. And I always like to preview it. The preview is actually going to let you kind of take a look at what's going to happen, what's going to look like when you receive it in the mail, what this board actually looks like when I receive it in the mail. This is in essence what you're going to be getting back. As you can see, the components appear there, your board outline, and you can flip it between the top side as well as the bottom side. So you can see what both sides are actually going to look like. Okay. Now from here, we're going to go ahead and launch what's called the CAM processor. Now this CAM processor is unique for circuit board designs only. This has nothing to do with the CAM processor that is used in the mechanical industry. This is the CAM processor for the circuit board industry. So I click here where it says CAM, and this is going to bring me to the CAM processor. Since it detected it was a two-layer board, it automatically brought up a two-layer template, as you could see there. So you don't really have to fiddle with it. Now, if you do have custom templates that you prefer to use, you could go ahead and load them. That wouldn't be a problem. Just click here, and you have some load. You select here, custom. You have some custom ones that we have as well, or you just go ahead and open up one that you may already have. Now, the CAM processor or the post-processing is actually going to generate all of my Gerber files. That's the name of the file format for circuit boards. That's the output that we use. It's also going to create the drill file, the bill of material, and the pick and place data as well. Okay. Now the Gerber files actually lets you preview what it's going to look like. So this is what the Gerber file for the top layer looks like, which is actually a combination of the top layer and the pads and the vias as well. The bottom copper layer, I don't have no traces, so it's very small here. My profile is my board outline, including the drill holes, our solder paste templates, and the silk screen for the top layer. Those are your reference designators and your values most probably. Now we don't have the values turned on. We only have the T-place layer, which is the board, the component outlines, and the T-name layer, which is the reference designators for every component. I'll go ahead and click on the option process job. And it's gonna, first thing it's gonna ask me is that where you want me to put these files. I'm just letting it go to my default, which is actually to the documents folder. There's a subfolder called Fusion 360, Electronics CAM. I'm just gonna let it go there. And they're right here. And this is where all my files are located, as you can see. Click open. It actually creates it successfully. I could select the option open my file or open my folder, and I can bring it over to the screen because I'm actually on a screened out, but actually it created all the files for me. Let me just see if I could switch this, that way you could see what I'm looking at on the side. Okay. There are my Gerber files, my drill files, as well as my assembly files. Okay, and it puts it in this directory that you see right here. Now you could take that and actually just go ahead and upload that to your whoever manufacturer you plan to use, or any prototype you would like to use. Now, this kind of completes going from schematic to board layout and taking the capabilities of some 3D PCB as well. Now, in addition to that, Fusion 360 does include a library editor. The library editor, I could invoke it by clicking on the file pull-down menu and select right here where it says New Electronic Library. This is the platform that you're going to be using to create your components. It actually takes 3 stages. We have our footprints, we have our symbol, which is what you see on the schematic, the footprint, which is what you see on the circuit board, and the device, which is the union of both of them. In addition to those 3 editors, we actually have a template package, IPC compliant package generator. In addition of actually creating the footprint, it will actually create the 3D model at the same time. Let's just use one here as an example really quick. So PLCC. Once I transfer all the data from the manufacturing into my template, I could click on Update Preview, and it will actually show me the component, the 3D model, as well as the landings that are going to show up on the circuit board, or the pads that are going to show up on the circuit board. It's building the component. Give it a minute. Now we'll be doing more webinars of this style, but we're going to be concentrating on certain areas only. So we'll be breaking them out point by point. Okay. So as you can see here, the 3D model is the portion on the top, and what you see here in the dotted lines, that's actually what's going to show up on the circuit board. They're going to be solid, of course, but this is what actually is going to show up on the circuit board. Well, this concludes what I actually wanted to present today. Everything that I wanted to cover was kind of like an overview of how to work with it and how to work with the manufacturing files, as well as how to be able to project an enclosure and bring it into my circuit board. That way I could use that as my template for my PCB from a schematic. So I appreciate everybody joining us. Are there any questions that I should be to cover, Jorge? Thank you, everybody, and have a great day.